Peace, 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 peace. It's me, Furious Black. I just did this video, quantum mechanics, and apparently I didn't record. So, without further ado, I'm gonna go through this again.
What is quantum mechanics? Quantum mechanics attempts to explain the behavior of subatomic particles at the nanoscopic level. Quantum leap. It is theorized that at the subatomic level, energy can only be released and absorbed in discrete indivisible units called quanta. This means electrons have fixed orbits around the nucleus of the atom as their energy comes in discrete amounts. When the electron gets excited or de-excited, they will absorb or emit a specific quanta of energy, which will mean they leap from one orbit to another without inhabiting the space in between.
Okay, so they're talking about an atom, right? See, in reality, atoms do not look like this. Atoms, okay, electron electrifies the atom, okay? Atoms actually don't look like this. I'm putting in what does an atom look like? Boom. Okay. Let me see. Right here. This is what an atom actually looks like. A cloud. Right? This is what it actually looks like. But they're just showing you what these things around this energy is doing. Light. Material world, the energy, light, that energizes all of this. So it's kind of like the Matrix when you're looking at materials, walls, cups, whatever. It's actually a cloud. Okay, kind of like this. Okay, so people they don't really know because science hasn't got down to the elementary level of kids yet, but it's actually a cloud. So they take some of that and then they do experiments with the material.
This is called the quantum leap. In essence, there are places within the atom that the electron will be likely to be, and other places where they won't, as energy is being absorbed and released in discrete units. Particles behave like waves. There's a famous experiment in quantum physics called the double-slit experiment, which revealed that particles display both particle-like and wave-like behavior. In a version of the experiment, on a larger scale, we have a gun that shoots tennis balls one by one at a detector, which will register where the tennis balls land. In between the gun and detector, we will place a barrier with two slits, which will leave openings for any tennis balls to go through. Over a period of time, and after many tennis balls, a pattern emerges on the detector, indicating where the tennis balls have landed. The results show that the balls which have not been blocked have landed directly behind the slits in the barrier. If we replicate this experiment, but on the subatomic scale and use electrons instead of tennis balls, we expect similar results. But this is not the case. Science has found that when the gun shoots electrons one by one toward the detector and past the double-slit barrier, the pattern that emerged on the detector looked like this. The electrons landed not just behind the two slits, but in narrow strips across the length of the detector.
So let's go back. Okay. Okay. A stable subatomic particle which is charged of negative electricity found in all atoms and acting as the primary carrier of electricity in solids. So that's what electrons are. Okay. It's the thing that animates us all.
and a significant number of electrons even landed straight behind the middle of the barrier. The pattern that emerged is an interference pattern and is associated with the behavior of waves. Imagine we have two waves that interact. The peaks of the waves will combine to form a higher peak, and the troughs will combine to create a deeper trough. And when a peak and trough meet, they will cancel each other out. So if we imagine that our electrons are less tennis ball-like and more wave-like, then what happens? This is a wave from above. The black lines represent a peak, and the spaces in between are the troughs. When an electron goes through the double slit, its wave is split in two, and these waves then interact. The peaks meet here and reinforce each other, creating higher peaks, and the troughs meet here, also reinforcing each other, creating deeper troughs. And here a peak and a trough meet, cancelling each other out. The interaction between the waves results in the interference pattern at the detector screen.
So, what is this? What is this? What are these? What is this? What is she telling you? This is the inside of you, your brain. This is the information your brain is receiving from the outside world. You don't know what this is, information. You don't know if it's true or false. It's going through your eyes, right? Your brain is collecting it and doesn't know, right? It's just like in my previous videos where the guy was talking about the five senses and your perception, your brain, what it means when the information hits these five senses. It is giving information to where you actually sit, which is within the brain. You sit in the middle of the brain, right? So this is all information from outside going inside to the person, right? Not knowing, unsurety, questioning in all of this, right?
Where the waves are most intense, we find more of the electrons on the detector screen. And where they cancel each other out, there are no electrons on the detector screen. Erwin Schrödinger came up with an equation for the electron's wave function, and Schrödinger came up with an equation on the detector screen.
So, these are the possibilities of the information that you received regarding what you already perceived throughout time. Whatever age you are, to that time, right? So these are the possibilities. The negative things is the stuff that you canceled out because it can't be connected to that thing because it's impossible. It happened in Chicago, but it's similar to something that happened in Oregon, but they're too far apart from each other. You feel me?
And where they cancel each other out, there are no electrons on the detector screen. Erwin Schrödinger came up with an equation for the electron's wave function, and using this equation, we can find out the probability of the electron being in a particular location. Think of the wave as a bundle of probabilities, and the size of the wave in any location predicts the likelihood that the electron will be found there if it is looked for. That is why on the detector screen we observe most of the electrons landing in the places where the electron's wave is at its most intense. It seems as if the electron is not in a fixed position, but has different probabilities of being in many different places at once. The act of measurement. To observe the electron's wave function going through both slits at the same time, detectors were placed next to the slits to capture this activity. But when this was done, something strange happened. The electrons stopped behaving like waves and went through one or other of the slits and landed on the detector screen to form the two-stripe pattern rather than the interference pattern. It seemed as if the...
So what's happening here? The eyes, the brain, what's happening? It's observing it and it's not making a wave pattern no more. It's making a two thing. What does that mean?
Act of measuring did something to collapse the wave function. The superposition principle. The superposition principle states that while we do not measure the electron for its position, it is in all the possible positions it could be in at the same time, and when we observe it, the superposition collapses.
Boom. Okay. So hold on. It, the superposition would be the preconceived notion that you have of the information that is coming into your mind, right? I was looking for uh, the box he drew with the mind. You know, this is a whole nother level of understanding the tree of life and all that. That's a whole nother understanding. I keep going to it, but not right now because that's not the point of this video. It's actually about, let's see if I put this in, if it will, if something similar will show up. Or you could just go back to the video that I had done before explaining this. Okay, yeah, I can't find it. But he drew a box with 5 openings showing the 5 signs, and the information coming in does not have doesn't have a superposition, right? Possibilities, right? But once you get to observing it, the possibilities are limited because you understand what is coming in to your eyes. You understand it. But if you don't understand it, there's more possibilities. This is why you're not supposed to jump to conclusions. So this is where she's talking about the information coming in and not having any solid ground or footing. But once you observe it, it does. It has a connection. And that's connected to biases, right? If you're biased, information will come in like this. Oh, Trump is bad, Trump is racist. I'm only using Trump because he's, the most recent situation of this. People won't even listen to the information because what's in here is already made up about the information out here coming through here. This could be the eyes, the ears, the mouth, whatever, right? A hot dog, you know what a hot dog tastes like. So boom, new foods, something you have a range of, what does this taste like? This tastes like chicken, beef, something new, alligator, whatever the case may be, right? Here, possibilities are massive. So that's what superposition is.
Do not measure the electron for its position, it is in all the possible positions it could be in at the same time, and when we observe it, the superposition collapses. So in this illustration, when our detector is off, our electron is in all of the possible positions or states it could be in simultaneously. But when we switch our detector on, the superposition collapses and the electron gives up all of its possible states to choose just the one. This is why we were not able to observe the electron's wave function going through the double slits. The very act of attempting to observe made the electron's wave function collapse. The electron gave up its superposition and chose just the one state to be in, i.e., the electrons actually reverted to particle-like behavior, and that is why instead of going through both of the slits, the electrons that landed on the back of the detector chose to go through either one or the other of the slits. Schrödinger's cat. Erwin Schrödinger described a thought experiment to further illustrate what quantum mechanics is saying about the electron and the superposition. He described a scenario where a cat was placed in a covered box with a radioactive sample that has a 50% chance of decaying and killing the cat. While the box is covered, we have no idea if the cat is dead or alive, and only once we open...
So that's the mindset you want to be in, right? You don't want to have a preconceived idea of what you think something is. You want to allow it to speak for itself, to mold itself, right? This all comes with how people get manipulated, right? If you know that people have these preconceived ideas, give them the ideas to sway their thinking. This is where indoctrination comes in, right? I did a video where the lady says we gave people the outcomes that we wanted. And out of those two, you could only pick from, instead of using critical thinking skills and think of 4 or 5 different other understandings. This is how it works.
In the box, will we know if the cat made it or not? So if the cat were similar to an electron, using the superposition principle, we would be saying that while the box was covered and the cat was not being observed, the cat was both alive and dead at the same time in order for it to be in all the states it could possibly be in. Only when we lifted the cover to observe the cat did its superposition collapse for it to be either dead or alive. Obviously, this feels intuitively wrong, and the reason why this thought experiment was employed was to illustrate how odd the laws of quantum mechanics are when it comes to describing.
So your brain is a quantum computer. It doesn't know what's outside of the window unless you say, oh, that's what's outside the window. You control that. The light within you.
Describing the behavior of particles. However, countless experiments have corroborated the results predicted by quantum mechanics. It does indeed seem as if particles have a wave function and that particles are in all the states it could possibly be in simultaneously until it is observed. But why do we see evidence of wave-like behavior from electrons and not cats? After all, cats are made up of particles. Well, the reason is, the bigger the object, the smaller its wavelength, and at the size of a cat, the wave is simply too small to be detected. Why do we accept quantum mechanics? The predictions of quantum mechanics has proved so reliable that we cannot ignore the experimental evidence that corroborates the theory. The entire electronics industry is built on using quantum theory.
Alright, so that's what quantum mechanics is. Your brain is a quantum computer, and the information that you receive either does this for you or does this for you. A closed mind only sees 2 possibilities, right? Just look at the world today. Why is the media giving you full negative stories on Trump? And why is Trump supposedly the most wicked man on the earth? That's what you have to figure out for yourself. That's why it's better to not have a superposition and allow the chips to fall where they may. Alright. Thank you for watching. Peace.